everyone. I'm Arham from Sri Venkateshwar College of Engineering, studying in the third semester in the Department of Computer Science allied with Cybersecurity. Today, here with the topic of scan disk scheduling algorithm. This is a topic in operating systems which we are going to learn and see forward. Scan disk scheduling algorithm. And what is it? Imagine you're in a library and you need to find several books scattered across in different shelves. You start from one end and walk down each shelf, picking up the book as you go. When you reach the end of the shelf, you turn around to walk back the other way, picking up the remaining books off your list. The scan disk scheduling algorithm also does the same thing. It is used in operating systems to efficiently access data and disk drive. It works by moving the disk head in one direction across the disk tracks, serving all the requests in that direction until it reaches the end of the disk. Then it reverses back and serves the remaining requests in the opposite direction. Scan disk scheduling algorithm applications. So where is this actually used? Scan disk scheduling algorithm can be used originally from disk access optimization in computer. As the picture shown, it can be used in elevators. The modern elevators use this algorithm. It moves the elevator between the floors in a similar manner efficiently to pick up and drop off the passengers. It is used in warehouse robotics. It is automated warehouses and robots are used to move items between the storage locations. Picking up the stations, the scan algorithm can be employed to optimize the movement in back and forth manner. It is also used in traffic management. It highlights the intersections and can be controlled by algorithms inspired by scan. The traffic signals can switch between green lights of different directions of traffic flow, ensuring efficient movement of vehicles. Document scanning and printing. In multifunction printers or scanners, a scan algorithm can be used to optimization the scanning and printing process in a back and forth manner. Program scan scheduling algorithm. I will actually run the code and show it to you. The scan algorithm and disk arm starts at one end towards the cylinder until it gets to the other end of the disk. At the other end, the direction and head of the movement is reversed. The servicing continues. The head continuously scans back and forth across the disk. C-scan is a variant of scan and designed to provide uniform wait time. Like scan, C-scan can move from one end to the another end in the disk. Here in the program, the initialization can be given as int T20, an array of size 20 to store track positions of disk request, int D20, which stands for size 20 of an array to store the head moment of the tracks. Int h is where the current position of the disk head is pointed. Int I, j, n, and k. These are loop encounters and indexing. Int temp, that is a temporary variable which is used for swapping elements during array sorting. Int array 20, size 20 array tracks arranged in order they'll be serviced by the head. Int TOT is a purpose that depends on specific implementation. Int sum is an integer variable used to accumulate total head movement. The initialization of the code declares the initials of n and h in the number of tracks and disks that generates n plus 2. Random track stores them in tracks array. The tracks array is the sorted in ascending order, finding the current head position. The code finds an index and the current position h in the sorted tracks array. Calculating the head moment. The code calculates the head moment in two parts, towards the left extremity and then towards the right extremity. Difference between the current track position and the next track position. The smaller of two moments is chosen as the total head moment. Printing the average head moment, the code calculates the average head moment by dividing the total head moment by the number of tracks. The average head moment is then printed to the console. Now I'll show you by running it on VS Code. So here we'll be running the code to see the number of tracks that should be traversed, and enter the position of the head, enter the tracks, and then there is logic behind it for scan disk scheduling algorithm. So if I run this code right now, you can see that it is showing me number of tracks to be traversed. I will write, I want 3 tracks to be traversed. Enter the position of the head, 1. Enter the tracks, one is 2, another one is 5, another one is 4. So the average header moments will be this. So this program you can keep on doing and checking how many tracks to be traversed, and then the average calculation will give the output average header moments. So if you run the code again, number of tracks to be traversed, I'll write 4, and then the position of the head is at 1. The tracks are 2, 6, 8, and 10. If I press enter, the average header moments will be 49939. So like this, you can keep on checking how many average header moments to be calculated in a scan disk scheduling algorithm.